Hello dear students, welcome to EC Academy Benefactor.
Dear students, the topic of the class is minimization of switching functions. Switching functions or Boolean functions. This topic is from the digital electronics subject, which is sometimes known as DLD or STLD also. So, in this class we will be seeing only the theory part, that is what are the different techniques of minimizing the Boolean functions or switching functions. So we can Boolean functions can be realized by logic gates. We all know that. That is, the hardware is designed using logic gates like OR gate, AND gate, NOT gate, and so on. So a Boolean functions are realized by logic gates. That is the hardware part. After simplifying the Boolean function, we are realizing this function or implementing that Boolean function using the logic gates, which is known as hardware. So while designing hardware, we need less number of gates to reduce the cost of the system. So this is a main aspect. So why do we need the minimization of switching functions or Boolean functions? Because the switching or Boolean functions are realized using logic gates, which should be minimum. For the implementation of a Boolean function in general gets reduced considerably if the Boolean function can be simplified. If the given Boolean function is simplified, what will happen? The gates for the implementation of Boolean functions get reduced considerably. So why do we need to reduce the Boolean function? To reduce the number of gates used for realizing the Boolean function, or for implementing the Boolean function, less number of gates are to be used. That is the reason we need to simplify the Boolean functions. Therefore, the simplification of Boolean function is very important, as it saves the hardware required. Hardware means here what? Logic gates, which are required for implementing the switching Boolean function. So what will happen if we save the hardware? By saving the hardware, it reduces the cost for the design. So the cost required for designing that Boolean function will also be reduced. I hope it's clear. Minimizing of Boolean function is done using logic gates, which is hardware. To reduce the cost of the design of the implementation of Boolean function, we need less number of gates. So there are two methods for simplifying the Boolean expression or Boolean function. What are the two methods? Boolean algebra, which requires Boolean laws, rules, and theorems. And the other method of simplifying the Boolean function is a map method, which is known as Witch diagram or Karnoff map or K method. Okay, K map method. So simplification of Boolean function or minimization of Boolean function is done using Boolean algebra or map method. So what is the drawback of the Boolean algebra method? That we need to go for the map method. Let us understand it here. In Boolean algebra method, what happens? We have to predict each step because it is used based on Boolean laws, rules, and theorem. So each one can apply a different law, rule, or theorem according to their availability of remembrance at that particular time, because it can be realized in a number of ways. For these reasons, we can never be absolutely certain that an expression simplified by Boolean algebra alone is the simplest possible expression. So as it is predicting at each step, we can't know that is it giving the simplest possible expression, because if it is simplest possible, what will happen? Gates will be less. If gates are less, what will happen? The hardware will be less, and hence the design cost will be reduced. So ultimate aim of the minimization of Boolean function is to reduce the design cost. So what happens? By simplifying using Boolean algebra, it is not certain that it's the only simplest possible expression. Okay, so now let us see what is happening in the map method. In map method, it gives a systematic approach for simplifying a Boolean expression. So there is a systematic approach for it, whereas in Boolean algebra method, it is predicting at each step based on Boolean law, rules and theorem. So it's a more systematic approach. The map method is a more systematic approach for simplifying the Boolean expression. So the map method was first proposed by Veitch and by the scientist Veitch, and then it is modified by Karnoff. Hence it is known as Veitch diagram or Karnoff map. Okay. So the K-map method is a more systematic approach for simplifying the Boolean functions. Then now let us see the K-map method. What is K-map method? The basis of K-map method is a graphical chart known as K-map. It contains boxes which is called as cells. So there can be 4 types of Karnoff map. The outlines are drawn here. So outline of one variable K-map, 2, 3 and 4 variable K-map is drawn here. One variable K-map, it means one variable means 2 to the power 1. 2 to the power 1 is 2. So it will have 2 cells like this. 1, 2, 2 cells. So variable A, it is having values 0 or 1. Okay. Now see for 2 variable K-map, this is one variable A. 2 variable K-map, variables are A and B. So variable A, it will have 2 variables now. So 2 to the power n. N means 2 here. 2 to the power 2 means 4 cells. So 1, 2, 3, 4 cells are there. These 2 belongs to values of A and these 2 are the values of B. So A is having value 0, 1. B is having value 0, 1. So this is how we draw the outline of 2 variable K map. Now coming to 3 variable K map. 3 variable means 2 to the power 3. It means it will have 8 cells. So variables we can take either in capital letters or in small letters. Any variable we can take capital A, B, C or small x, y, z. So 3 variable K-map can be drawn either in the horizontal way or in the vertical form. If it is drawn in the horizontal way, we can write the one variable here A and other 2 variables on this side A, B. So A will have what values? 0 and 1 and B, C means combination of 2. So it will be 0, 0, 0, 1, 1, 0 and then 1, 1 here. This is how it is the outline of the 3 variable K map. So we need how many cells? 8 cells. 0, 1, 3, 4, 5, 6, 7, 8. 8 cells. Now coming to if it is drawn in the vertical manner, then I have taken these 3 variables x, y on one side and z on the other side. X, y means 2 variables. So it will be combination as 0, 0, 0, 1, 1, 0. This has to be 1, 0 here and then 1, 1. And it is z variable 0 and 1. Z is a single variable on this side. It will have either 0 or 1 value. Now coming to the outline of 4 variable. 4 variables means how many? 2 to the power 4. It means 16 cells. So the 4 variables which I have taken here is A, B, C and D. So AB on one side, CD on the other side, total 16. So we'll draw this like this. First let us draw one box and like this. 4 vertical lines and 4 horizontal lines like this. So it will have total 16 cells in it. So AB 2 variables, so write their values as 0, 0, 0 1, 1 0 and 1 1, and CD values is 0 0, 0 1, 1 0 and 1 1. So this is how they can draw the outline of four variables, one variable, two variable, three variable and four variable Karnaugh map or K-map method. So in this class what we understood is how can we minimize the Boolean functions and what are the different methods. I hope it's clear now. The Boolean functions are to be simplified for realizing using logic gates. Why need to be simplified? To have less number of gates so that the hardware design will require less number of gates and hence the cost of the hardware will be reduced, and which will make the work as cost effective work. So for this, simplifying the Boolean function or minimizing the Boolean function can be done by either Boolean algebra using Boolean laws, rules and theorems, or by the K-map method, which is a more systematic approach, and we'll see how to solve the problems using K-map method in the next class. Thank you. All the best.